In this video, we present to you a guide in Mathematics 7, Quarter 1, Module 1, Week 4, with the topic, the properties and the operations of integers. Through this video, you are expected to illustrate the different properties of operations and the set of integers. The properties of real numbers. First, we have the closure properties. Under this one, closure property of addition, which states for any real numbers a and b, a plus b is a real number. For example, 5 plus 3 is equal to 8. Why? Because 5 is an element of the set of real numbers, and 3 is also an element of the set of real numbers. Thus, the result, which is 8, should also be an element of the set of real numbers. We also have the closure property of multiplication, which states for any real numbers, a and b, a times b is a real number. For example, 5 times 3 is equal to 15. Why? Because again, 5 is an element of the set of real numbers, and 3 is also an element of the set of real numbers. Thus, the result 15 should also be an element of the set of real numbers. Commutative properties. We have the commutative property of addition, which states for any real numbers a and b, we have a plus b is equal to b plus a. For example, 4 plus negative 3 is just equal or the same when you say negative 3 plus 4. Because when you are going to simplify this one, the result is both 1. Thus, commutative property would mean no matter how you order the addends, the result is still the same. We also have the commutative property of multiplication, which states for any real numbers a and b, we have a times b is equal to b times a. For example, 4 times negative 3 is just the same with negative 3 times 4. Why? Because when you are going to simplify both sides, the result would still be the same, which is negative 12. So in other words, when you say commutative property of multiplication, no matter how you position or you order the multiplicants or the factors, the result is still the same. We also have another property of real numbers, which is the associative properties. First, we have the associative property of addition, which states for any real numbers a, b, and c, we have the sum of a and b plus c is just the same with a plus the sum of b and c. For example, the sum of 3 and 4 plus 5 is just the same or equal to 3 plus the sum of 4 and 5. Because when you are going to simplify both sides, you are going to come up with 12. In other words, when you say associative property of addition, no matter how you group the addends, the result is still the same. We also have what we call as the associative property of multiplication, which states for any real numbers a, b, and c, we have the product of a and b times c is just the same with a times the product of b and c. For example, the product of 3 and 4 times 5 is just the same with 3 times the product of 4 and 5. Because simplifying both sides, the result is the same, which is 60. In other words, when you say associative property of multiplication, no matter how you group the factors, the result is still the same. Another property of operation for real numbers is the distributive property. When you say distributive property, it states that for any real numbers, A, B, and C, we have A times the sum of B and C is just the same with the product of A and B plus the product of A and C. For example, 3 times the sum of 4 and 5 is just the same as you say the product of 3 and 4 plus the product of 3 and 5. Because when you simplify both sides, the result is still the same, which is 27. So how did we come up with this one? Simply with the word distribute. We simply distribute 3 to each term inside the bracket. So that would mean we distribute 3 to 4. So that's why we came up with 3 times 4. And distribute 3 to 5. That's why we came up with 3 times 5. Next property is the identity properties. First, we have the identity property of addition, which states, for any real numbers A, there exists a number 0 such that A plus 0 or 0 plus A is just equal to A. For example, 3 plus 0 or 0 plus 3 is equal to 3. With this, we could see that any number added by 0, the result is just itself. In other words, we could say here that 0 is our additive identity. Second, we also have the identity property of multiplication, which states, for any real number A, there exists number 1 such that A times 1 or 1 times A is equal to A. For example, 3 times 1 or 1 times 3 is equal to 3. With this, we could say that any number multiplied by 1, the result is just itself. From this example, we could say that 1 is our multiplicative identity. Another property to discuss is what we call as the inverse properties. First, we have the inverse property of addition, which states for any real number A, there exists a number negative A such that A plus negative A is equal to negative A plus A is equal to 0. For example, 3 plus negative 3 is equal to 0. In our example, we could say that negative 3 is our additive inverse. When we say additive inverse, we could simplify it as the opposite of the number. So in other words, any number added by its additive inverse or opposite, the result is 0. We also have an inverse property of multiplication, which states for any real number A, there exists a number 1 over A such that A times 1 over A is equal to 1 over A times A, which is just equal to 1. For example, 3 times 1/3 is equal to 1. From our example, we could say that 1/3 is our multiplicative inverse. In simpler term, multiplicative inverse is just the reciprocal of the given number. Thus, we could say that 3 or any number multiplied by its multiplicative inverse or its reciprocal the result is always 1. Now, it's time to check our understanding. Let's try to answer activity 1.1. Know me. Direction. All you have to do is to name the property that justify each of the following statements. Example, number 1. 5 plus 6 is equal to 6 plus 5. What property do you think that could justify this expression? Yes, you're correct. Commutative property. Now, I'll leave numbers 2 to 10 for you to answer.